Hello, everybody. Yeah, SQL for Django. It's mostly a talk because, yeah, well, let's start it right at the beginning. I'm mostly a Python user and an occasional Django user. So Django is not really my original focus, which is why I learned SQL before I learned Django. And I always went back and forth between either using the Django ORM to implement something or using just a SQL statement. And I realized, well, I think we most have, that maybe not so much in our community, but in many communities, there are strong opinions about whether an ORM or using SQL or query builder is the right approach for a particular problem. So I just like to share my thoughts, my finding, not to tell you what to do, because that ultimately depends on what you are more comfortable with and what your application demands. But maybe just to give you some thoughts if you are on one side of the spectrum, or M user, or the other, a SQL purist. Okay, now the good news, and maybe I'll already share the conclusion, is that in Django you can decide both to use the ORM and, well, basically as a query builder in the ORM, and you can decide to use SQL. You even have multiple ways in which you can use SQL, depending on how much you want to use Django functionality or want to, well, be very specific on the terms under which you connect to your database. So Django is a large toolbox. And, well, probably speaking, we have two hammers for our particular problems, and we can use both. And yeah, let's maybe start with some, well, preconceptions almost about things where an ORM should work well and where SQL is the right approach. And for the moment, let's just assume that we go for an either-or approach. So you would write an application and you want to decide, I want to do either everything in SQL, whether it's practical in Django or not, or I just want to use the ORM and I never want to know anything about SQL or my database in general. Now, what an ORM always gives you is very nice, comfortable functions to create objects, manipulate them, delete them, get something that you can pass into a view, iterate over, and ultimately render. It's very, very comfortable. In SQL, you'll have to do most of that by hand. So you'll have to write some queries, and then you'll have to write tons of boilerplate code to actually, well, have objects that you can pass along. You have with an ORM, be somewhat careful if you work with complex object hierarchies in order to, well, not to run into too many or too inefficient queries. In SQL, you see what you write. So you see at least your query expression. You don't normally know what the optimizer is going to do with it. So you'll have to do more work, but maybe it's not so likely that you'll step into any particular traps. And if you work with analytic queries, so if you don't want to have objects, sometimes you need to think about, or you normally know how your data should be structured. So you have some, let's say, a specific table in mind. And then you'll have to think on how do I best express this with the methods of the ORM. Well, on the other hand, you can directly work with SQL. So what we already see is there are different scenarios, and depending on the scenarios, we might prefer one solution or the other. Now, one idea could ultimately be that Django's ORM can only work with simple objects, and for everything else, you need SQL. Especially if you talk to other people and compare Django to SQL Alchemy, you'll often hear that SQL Alchemy has this nice expression builder and is more capable, and that Django is quite limited. I don't know the details of both systems, but what I found in my work in preparing this talk is that basically everything I want to do with Django and the ORM, I can do with Django and the ORM. Just to let you know, this is my small example database. The only thing that you need to notice is that it is quite join heavy. So I have quite a lot of foreign key relationships in there, just so I can show you well, how things look if you work with multiple tables. And then there are, well, some dates in that. It's basically an order database. You have customers, you have salespersons, and you have products that are sold. Okay. Now, We'll look shortly over multiple scenarios on how to use the Django ORM, and we will compare them to the SQL that Django creates in the background. The motivation is, well, twofold. First of all, to see how things look in Django, and also how they would look like if you did them in SQL. So first of all, and we can keep this extremely short, you can work with objects. So I can create one of my customer objects, Mr. Example, who has a discount ratio of 10, and then I can work with this customer, change his discount, delete him again, etc. It's just, well, what we do every day. And here I don't even see the SQL because I guess you can imagine it. And the interesting thing is that this particular use case, at least in my experience, accounts maybe for 70% of all queries that I do, that I just want to have some specific objects, manipulate them, pass them into a view, and then be done with them. Now, of course, we can filter them. And here things already get more interesting because here if we look at the SQL as well as at our Django query, we already see that they are quite close to each other. So I say, where do I want to get my information from? How do I want to limit the information that I get? With Django, do I do with these two filter clauses? I can limit the information I want from a database, so I don't select the whole customer object, just the last name. And then I can order by discount. And you can see the, well, SQL query does not really provide any surprises. So I think this is very familiar, and this is still something that I can, well, read quite well. Now we can, of course, get more complex, and I apologize for the rather tortured example. I don't know why I wanted to just multiply the discount. But as you can see with the field references, if you just want to have a filter that refers to other fields or to the same field twice, it's easily done. And well, again, it almost looks like what we would do in SQL. So we can get our minimal object manipulation. And also we can get from Django just the data that we want. So just the last name of a couple of customers. Of course, I can also build a more complex query. So if I want to combine two query expression with an OR, I can do this in Django, and I can do this in SQL. So far we say Django and SQL scale quite nicely, but just looking back and forth, we usually see that our Django solution is smaller for the simple cases. It's not so much writing. And of course, I can also do annotations. So if I want more than just a common object, I can add some extra information. I can say the information that I want. So here I want to have the doubled discount for what reason whatsoever. I can also filter by specific IDs. And again, what we get in SQL looks amazingly. Well, we were at the similarity between SQL and Django. And in the interest of time, I'll just rush things a little bit along. So what you can see is, especially, you can do all the interesting, more or less analytical queries, joins, annotations, etc., that you might want to do in Django. And it's usually shorter than in SQL. So in Django, to go over a hierarchy or, well, some relations of different tables, you just have to combine them. In SQL, you'll have to write quite a bit of joins. So, and of course, you can do aggregations in Django. So even simpler analytical queries where you don't really want to have objects, but just want to have some, well, sums, averages about information in your tables, you can do this. And it's, again, well, not much code in Django and also not too much code in SQL. So yeah, you can go along. And if you wanted to do really quite interesting tables, so if you wanted to go join information about customers and salespersons who are the other ends of the object hierarchy, and wanted to combine some information about them, and then wanted to order about specific date ranges, you could do this in Django, and you can do this in SQL. And now, well, we're maybe a little bit a victim of code formatting here, but you might think, at least I do, that at this point in time, this Django query also looks quite complicated. So we maybe at a certain point in time, we lose a little bit about the readability that we are used to. And yeah, this is basically one of the reasons
Fica
why
uma
I
etapa ali.
sometimes go back
Tem
to
duas más,
SQL
uma
to
com
look at my
quatro
task.
massas, uma
Of
omelete e um
course,
bife.
there's also one other example that always comes up if people talk about problems with ORMs. That's the one plus one query problem. So let's say that I wanted to have all my orders, and for all orders that I have, I wanted to give print some information about the associated customer and salesperson. And knowing Django, you probably know what will happen here. I have just one query to get my orders, and then for each salesperson and customer, so for each order, I have to send two queries again to the database in order to, well, make sure that I have all the information that I need. In this example, I had about 1,000 orders. So I have slightly more again. So ultimately, I ended up with 3,000 queries.
Então,
And that, while every query in itself was simple, that took a while, of course. It's not hard for us to solve this issue. So just add some select related. But this is a point where maybe the abstraction that the ORM provides us with does not actually help us anymore, because now we have to think not only about what data do I want to have out of my database, but also how do I structure my query in my database model in order to make it easy for Django to give me the right things in a performant way. And I think most of us have, well, set in front of their application and had a little counter going how many database queries for a specific page were fired, and then trying to optimize things down so, well, performance gets better and there are less queries executed. Yeah, and this brings me to, well, to all the good things and maybe the bad things in Django, and just to compare them and how things look for SQL. Now, why do I want to do this? So my main reasons was Django ORM gives us everything, but SQL can give us other things that are also nice to have. And just as an example, the previously mentioned query problem, writing it in SQL and getting all the information that I need, I think it is clearer looking at the SQL what we want to accomplish. So we just can specify all the data that we need. We can just say how we want to join this data, and then we can execute it. We have a certain, let's say, separation from the data that we want and from the data processing part in Django. And well, of course, we execute exactly the SQL that we've written previously. That means that by using SQL for complex queries, you can achieve a certain separation of concerns. Where normally you would need to think about the Django query and how you want to process it, you can first think, how do I want to, what target data do I want? And then basically, we factor all your query logic, all the thinking about how do I best get it into a SQL query. And then from the SQL query, either build some objects to pass into your views, or, well, just use the data as it is. So that can be helpful because it makes one complex problem into two smaller ones. There is also sometimes this performance optimization problem. So oftentimes I mention it, I find myself in a situation where I write something, where I then look why it is not performing as I'd like to, and then look at the queries, and then start to optimize. Whereas in a SQL world for such complex queries or queries that you run especially often, you could just write the SQL, maybe optimize the SQL, and then integrate your information into Python, which again breaks the problem down. For me, it makes it easier to think, but well, it depends. It is also again an issue where you can, well, how to break down your code. SQL has come quite a way since, let's say, the early 2000s in terms on how you can structure your code. And for example, with this thing, a common table expression, you can just use basically subselects to define temporary in-memory tables, normally not persisted, that you can use in other queries. So you end up with really quite readable code and also quite modular code. and not these, let's say, monster queries that, well, we often dread and fear if we think about SQL. And for persons like me who are slightly lazy and use an EDI, writing pure SQL, if your IDE knows about the database, is also quite easy and fast because you get code completion for your database. Your IDE looks and how your tables are structured, and yeah, you don't really have to down all the join clauses, all the things that you want, but you can just concentrate on simple things. And this is something that, well, with Django, even with good IDEs, you don't get to that extent. The IDE does not necessarily know how your model is structured, especially if you use these filter syntax with the double underscores to access different functions and fields. Yeah, and ultimately, and that sometimes comes up in my daily work, is that I work with more people who know SQL than who know Django. So if you have business analysts, data scientists, or even some business users, and they want to specify a specific dashboard, they will sometimes find it easier to specify a SQL query that they want than to give you the exact details in a Django query. So SQL can also serve basically as a lingua franca, as a method of communication between different fields. And this also applies if you work with colleagues who are maybe not from the Python world, but if you have another team with another microservice using Java or Go to offices over. Yeah, and the last thing, again, I'm slightly lazy in this regard, is if you want to know how to, well, basically wrangle data into a specific format or how to do a sliding window function, things that get more complicated, it is usually easier to find answers in SQL, even if they're not for your specific database, and then adapt them to your database, than it is to find, let's say, up-to-date information in Django, because, well, Django develops and changes a bit. These are my main reasons why I find SQL instead of the Django ORM interesting in some parts. Now, the good news, of course, is we don't have to decide on either or. And this is what I found extremely, well, made me quite happy when I realized how many possibilities I have. So I don't have to ignore Django ORM and all my objects and my, well, nice models, but I can just say that for a specific model and the query manager, I want to send a SQL query, and the SQL query will then return the data that I need to build my objects. And then I'll have a list of objects, well, more list of objects in a query set, which I can use in my views or which I can iterate over and which I can save. And that is quite flexible. So as long as the data returned from your database query is what Django expects as fields for the model, you can do whatever you want. So here I have this, let's say, pseudo SQL where I just defined some literals, and I can consider this a specific object. So you can, if you want to have read-only access, be quite flexible in where you get the data from that you would like to use. And you could maybe even use existing object definitions with databases that do not conform to the scheme that you got there, if you want to. You can even say that I just want to select some data. So maybe I just need the idea and the first name in a list view, and I want to only show the last name and the discount or any other object attributes when I go to details. And Django will do the right thing. So it will get the objects based on the ID. You will have already in memory the first name, but you can look up the last name. This will end in an additional query, but the good thing is it will work. And of course, you can pass in parameters. So if you want to protect yourself from secret selection, SQL injection attacks, Django has you covered. It uses a slightly different syntax that you would sometimes be used to, which is basically, well, old style string quotation. But you can put in an array of parameters and you get what you want. So if you're more familiar with SQL, if you, as I am, if you sometimes like to read SQL more than reading Python code, it's a quite good way to get the data that you want. Of course, you also lose something. For example, if we send a query asking for specific customers and we use this filter criterion and we only want to have the one with the highest discount, by default, the SQL query will give you all the data, and your query set will have all the data. So this is executed earlier than we would normally have in Django. And to get only the first thing off the list, you'll have to, well, write your SQL query accordingly. The same goes basically for pagination. So again, sometimes you'll have to see what queries get executed in order to not be surprised on how many there are. You can also use this raw SQL approach for annotations. Of course, there are additional, you'll have to be especially careful so that you annotate the right data with the right data. But you could, for example, decide that you have some rather complex query that you'd like to have to annotate your customer objects, and then use a standard Django query and annotate with a raw SQL statement. This, again, might be of interest if you already know how your business users or your domain expert structure their queries, and you already have queries that you can reuse. Now, this was raw SQL. So again, what it gives us is the ability to use our existing models with handwritten queries. So I get model instances back by handwriting a query and sending it to the database. I don't have to do that. We can additionally just say, okay, I get one connection from Django's connection pool, and I use it almost like a normal Python database call. So you can write your SQL, execute data, and you get rows. And then you'll have to build your objects yourself, or if you don't need an object, don't do that. So this is very nice if you don't have an object that you should return, but maybe a purely analytical query. And of course, you are always free to bypass Django directly and just go directly for the database driver, SQLite in this case, but it could be Postgres or anything else supported by Django or even not supported by Django that you wanted to use. And then you get the, well, additional things that you can use database driver specific functionality. It could also be interesting if, for example, you have a Postgres instance with PG Bouncer, and you, for some of your queries, you want to use functionality that is not supported in your PG Bouncer configuration, depending on your session management. So, well, we have many opportunities. And then in the interest of time, because of my hiccup, I'll just say the problem, of course, is boilerplate code. Writing just pure SQL can be quite long, but the good news is we don't have to do that. Another drawback is loss of abstraction. So if we write SQL, we normally don't have nice objects. Again, that's not true with Django. With Django, we can decide to use SQL to get our objects and to a certain extent have the best of both worlds. And of course, we would, if we completely work without Django, use many nice features in Django, but we don't have to do that. What we do have is choice. So we can decide for different parts of our application to use the ORM, or to use raw SQL and still get objects, or to use the Django connection pool and send SQL, or to use native connections with database. And we can also decide, in principle, to use Django models or use the data description language of SQL. So basically building our tables by hand. And with this mix approach, you can basically have the advantages of the ORM and of Django in one application. So you can use Django models to define your database, to have nice migrations, and then use SQL for queries where you're saying that maybe Django is slightly too complex, or where you really have to fine tune how do you get your data and how you speak to your database. Yeah. Ooh, caught up. I hope I didn't rush you along too much. Again, sorry for the interruptions. And if somebody could just, again, bring the link to this Q&A session in the chat, because again, my computer went down and I just lost some browser windows. Okay, hello again. You're so much faster than I am.
Hi.
Can you indicate whether you can hear me, please?
Yes.
Okay, great. So the output device is still wrong. Give me a second. Okay, so now it should work. Okay. Are there any questions? Stunned silence. You know, if you don't have questions, I will just keep talking. And that might get boring. So okay. So
Hello.
hello.
Hi. Very interesting. I have a personal connection to this topic because I worked using Django a few years ago with a very big, let's say, analytical workload project, and it was very interesting to see this happening because I was kind of pushing for it back then. In the end, it got rejected because everyone preferred to use the ORM. And the reason was very strange in the sense that some people knew more how to use the ORM than how to read and write SQL, which is the opposite of what you just kind of showed. And I wanted to ask you, what's your opinion on the maintainability and evolution of this? Also, because, for example, if you have changing Django models somehow often, then you have to adjust all your SQL code. Also, you would have to adjust all your model code. But anyhow, what's your opinion on this?
Yeah, the question was if you have to change both, and I think the solution need to be both the same. So what's the Django code? You would write test cases to, well, basically you would mostly discover it during a normal smoke test because if the model instances are different, it will be quite obvious. And you would need to do the same with SQL. So what I usually do is put the SQL statements into a separate file. So a SQL file and just use comments to basically grab the SQL out and put it into Django. And what you do there is just to ensure that the SQL queries for a defined data set still return results and the right results. And you can even go the way that you say, this SQL statement should result in this Excel, or it did result in this Excel. Let's say you take the first 100 rows or so, and then just do basically a comparison test. Did anything change that we would not expect to change? And then you should see whether things still work and whether they still get the same results. So, well, I think it's, like I said, ultimately, if you change your model often, you'll have to change your code. You can, of course, abstract if you say, I have a layer even above the model layer where I just work with, let's say, query business objects, where I already have pre-aggregated data or something like that to localize the changes. But I think this is not, again, specific on whether you use the ORM or whether you use SQL statements.
Thank you.
Thank you. Yeah, it's interesting. So another interesting use case, I think it was in Django 2, 3.2, where there was some new changes with the interface to JSON fields. And this can also be something where things might get interesting if you use something that is very specific, quite new, maybe even database specific. I mean, we have this strong relationship to Postgres, and you really want to use this, and it doesn't fit your object model. So yeah, it's strange. I think ultimately it comes down to your questions, liking the ORM or not, what you learn first. So for me, it was SQL because we did this in university back when we learned C. It was much worse SQL back then, not even the nice join statements that we have now. But well, that was basically the first. So I could always in my head express things. Okay, I like this data table. I know how to do this in SQL. And now I have to translate to Django. And for somebody else who has worked more with Django and has to translate it into SQL, it will be the other way around. So I think there are just benefits in knowing both because both have their strengths and weaknesses. And well, just one thing with the ORM, you saw that I included always a query that gets output. to a certain extent, you'll have to understand and read these queries. So especially if you're not 100% sure whether you did use Django right, you'll have to check whether the query, the join criteria, etc., are what you imagine they would be. So you should have a reading relationship with SQL, I think. Okay, anybody else? You know, I just see this wonderful wall of letters: M, I, G, C, J, M, M, G, M, S, D, B. Okay, then. I think the slides will be published. So if you have any asked questions or remarks later on, so if I made some dreadful mistakes and
I think you have a question on chat.
Oh, sorry. Yes. Could you read it because I'm technically overwhelmed and didn't see the chat?
Yeah. It's on this chat here. There's a button down there to open and close it.
No, I see it. Okay, yeah, my fault. Excuse that.
Yeah.
So, but about safety of like migration signals, etc. Yeah, we went slowly into that. So in terms of SQL injections, if you use the way to pass in parameters into the raw SQL statement, Django has you covered. If you pass in your own hand-built strings, then it will, well, you're vulnerable. So there applies some protection, like equally as when if you put some statements into the ORM, but it is quoted. In terms of signal migrations, if you continue to use models, so if you define your, well, database models in Django models, then you can keep migrations. Of course, as we talked about in the previous questions, you may have to change queries. So there's no auto migration for the SQL just generated that you write. And in terms of signals, to my understanding, no. I would also, truth be told, I haven't tried it because I'm afraid what will happen. You could, in theory, use arbitrary SQL statement to return model instances and then try to save them. So you could query one table, get a model instance with an ID and save them back, and then it would save back to the original database. If you continue to use the Django ORM for the parts where it is better, then you could also get signals. However, that could mean that you use two queries. So you would use one query to get the data on the objects that you want, and then you change them in Django objects. So basically you use SQL for reading and Django objects for writing. And then of course you get the signals. Okay, then. We have 4 minutes left, so anybody wants to do anything again? Otherwise, like I said, there is my email address on the slides. So if there are any further questions, corrections, especially interested in corrections, please let me know. And otherwise, enjoy the rest of the conference. I think we have some very nice speakers this year.
I have an example of a scenario where raw queries can be useful, which is like you were saying earlier, when using some specific database function. So as an example, I'm using a foreign table on Postgres. Basically, it's another server, a table on another server exactly. And sometimes you do need the raw queries. There might be a way to use the ORM to improve this, but most people will firstly get this to work with the raw queries. To turn this into a question, do you have any other typical examples like this where some tools that are database specific that you're using and you find that you need this solution?
I think it mostly covers it. So if you know how to do things in the database, and well, maybe Postgres JSON-B tables come to mind, which have a quite particular syntax. And I think I support it now mostly, but if you already know how to do it in the database, then it's mostly easier to just adapt the SQL to a raw SQL. Same as you said with functions. So I think it's possible. You can have some wrapper objects that you can use in the ORM, but it might just be easier to use a raw SQL query there. So thank you for the example. Okay, then. Guess it's more or less closes it. So, everybody, have a good, nice conference. And as I said, any further questions, please get in touch.
Thank you.
Thank
Have a
you.
good one.
Have a nice day.
Bye.
Thank you.